Periodic classification. Since there are a number of elements known today, hence there felt a need of classifying the elements in such a manner that if you have studied about one element, you can predict the properties of other elements. Dear students, periodic classification helps you to identify the element, to predict its properties, to detect its position in the periodic table. And in the periodic classification, we will study about the properties like atomic size, ionization energy, electron gain enthalpy, electronegativity, nature of oxides. A number of scientists tried for the classification of elements in the periodic table, and the most successful was that of Mendeleev, which was further corrected by Moseley with the discovery of isotopes. Although Mendeleev worked a lot and got a lot of appreciation, but the last man who classified the elements was Moseley, and his classification was perfect because no two elements have the same atomic number. Now the first question which you can get in this chapter is, he can give you the atomic number of the element, or he can give you the electronic configuration of the element and ask where the element exists in the periodic table, what is its group number, what is its period number. So here is a question: an atom of an element has valence configuration argon 3d2 4s2. It is present in, now the choices are fourth period, fourth group, third period, third group, second group, third period, second group, fifth period, fourth group, or fourth group, sixth period. How to identify? You see, if it is an S block element, then the electronic configuration will be NS only, and before this it will have the stable configuration, that is to say n-1 S2 n-1 P6. If there is one electron in the s orbital, it belongs to first group. If there are two electrons in the s orbital, it belongs to second group. So the period number will be decided by the n. Whatever is the maximum value of n, that will tell you the period number. In this case, the value of n is 4. So the period number is 4. Now how to locate the group? If it is a p block element and the configuration is ns2 np3, then the group number will be equal to 10 plus ns electrons plus np electrons, that to say in this case 15, but here the last electron enters into d orbital, so it is not a p block element, it is a d block element. For d block element, the group number is equal to n-1 d electrons plus ns electrons. So 2 plus 2, 4, hence it belongs to fourth group. So you have seen that period number is given by the principal quantum number, which is n, and the group number for s block, it is equal to the number of electrons in the s orbital. For p block, it is 10 plus ns plus np electrons. For d block, it is n-1 d plus ns electrons. After this, the general characteristics regarding ionization energy or atomic size or electron gain enthalpy. So you very well know that ionization energy depends upon size of the atom, its electronic configuration, then the number of electrons present in the inner energy level which are responsible for shielding effect, then the fully filled or half filled orbitals, or the type of orbital from which the electron is being removed. Suppose you get a question, which of the following will have maximum ionization energy? First of all, see that if any of the element has got stable configuration, in this case you are saying there are two elements, sodium and neon, both have stable configuration, both are isoelectronic. Neon has got ns2 np2 np6, sodium also has got ns2 np6. In both the cases the value of n is 2. Now second thing you have to see is which of the two has got the greater nuclear charge. Then sodium has got atomic number 11 and neon has got atomic number 10. It means sodium has greater nuclear charge. So in this case the answer will be sodium plus. Although we have a wrong conception in our mind that noble gases have the maximum ionization energy, no doubt they have maximum ionization energy provided they are not isoelectronic with any other cation. If they are isoelectronic with the cation, then you please see that if they have the same configuration, valence configuration, then one which has greater nuclear charge will have higher ionization energy. In this case, all the 4 species are isoelectronic. So in this case, ionization energy will be minimum for oxide because it has got the minimum nuclear charge. Then for fluoride, which has got more than this. Then for neon, and lastly for sodium, that is sodium ion has the maximum. Now electron gain enthalpy. Like ionization energy, electron gain enthalpy also depends upon the size. Smaller the size, greater the electron gain enthalpy. Nuclear charge, greater the nuclear charge, greater the electron gain enthalpy. Then electronic configuration. If the configuration is fully filled, then electron gain enthalpy is either 0 or positive. Now the question is, which of these have maximum electron gain enthalpy? Oxygen, sulfur, selenium, tellurium. Dear students, in this group, electron gain enthalpy of oxygen is minimum, although it should be maximum. You must know it is an exception. Third period element has, like oxygen, has less than sulfur. Fluorine has less than chlorine. There the case is the electron enters into third energy level, whereas in fluorine and oxygen it enters second energy level. Second energy level is smaller in size. So a part of the energy is used to overcome interelectronic repulsion. Hence these are the exceptions. Fluorine has less than chlorine, oxygen has less than sulfur, nitrogen has less than phosphorus. But you must know this very clearly. In this group, electron gain enthalpy of oxygen is minimum. I am not considering the sign. It is the value which I am taking into consideration. Now, if you get a question, why out of O plus, O minus, O2 minus, which will have the maximum value of electron gain enthalpy, then dear students, it is the O positive, because its configuration is not fully filled. O minus will have positive electron gain enthalpy because energy will be required to overcome interelectronic repulsion. You must keep in mind that for an anion we have to supply the energy in order to give the electron. Next, the question, which of the following processes requires absorption of energy? Just now I told you, whenever an anion is accepting an electron, energy has to be supplied to overcome interelectronic repulsion. So in this question you see, which of these is an anion? No one is an anion. Now again look at the configuration. One which has stable configuration, if you want to give the electron to that species, it will be exothermic, it will be endothermic. So the answer is magnesium. Why magnesium? Because magnesium has fully filled s orbital. Instead of this, you can get in the choice you can get noble gases. They will also have positive electron gain enthalpy. That is, say, heat has to be supplied. You can also get in the choice you can get O minus or F minus anion, because again energy is to be supplied. Now after this, the nature of oxides. If an element is in the lower oxidation state, in the oxide form, then it will be basic, because in the lower oxidation state they lose electrons, and it is the metal which loses electrons, so the oxide will be basic. In the higher oxidation state it will be acidic. In the intermediate state it will be amphoteric. So out of these, manganese oxide will be acidic in nature, it will be basic in nature because it is in the lowest possible oxidation state. Mn2O7 will be acidic in nature because it is in the highest possible oxidation state. You can